Hi, everyone. Thanks for being here with us today. I'm Rafet. I'm going to talk to you about integration tests with Godog and test containers. Very briefly about myself, I'm a senior software engineer at Deliveroo. And if you ever want to reach out to me for questions or feedback, please feel free to do so. I'm on any respectable social media platform. So what we'll cover today. So first, the test types. We'll think about the terminology only very briefly. And then I'm going to talk to you about the benefits of integration tests. And then basically, I'm going to talk you through how we do with Godog and test containers altogether. So terminology review. Most of you are probably already familiar with the testing pyramid. Basically, at the very bottom, you've got unit tests, which cover small atomic units like functions, methods, or classes. They provide very quick feedback, easy maintenance, and very high test coverage at a very low cost. Next up, you've got your integration tests. So these basically cover interactions between different units or components. You're often testing services, APIs, databases, caches, and communications between these components. And what you do is you verify if these components work together as you wanted. And basically, you detect communication issues or validate your data integrity. And at the top, you've got end-to-end tests, which cover your system as a whole and usually run on a real environment. These simulate real user scenarios, and they involve multiple components and systems communicating. And then they help identify high-level issues, ensuring your complete system behavior. And then very quickly on behavior-driven development, in case you're not familiar with, this basically describes your software behavior using natural language like English. And that is easy to understand both by technical and non-technical individuals. What you have here is for each scenario use case, you've got a context given, which is say given I've got a promotion set up for a restaurant, an action when I call my promotion service, and an expected outcome would be then I receive a promotion as response. This basically encourages collaboration among engineers, product managers, and other stakeholders. And this collaboration helps ensure that software behavior aligns with business goals. So I know it's a bit boring so far. I hope I didn't lose many of you. I promise it's going to get a little bit more interesting. Not a lot, but a little bit more. So I'm going to talk about integration testing pros. 5 seconds to appreciate the GIF. So yeah, why should you be doing integration tests? You test your communications and data flow, right? Yeah, so you verify that components can exchange data correctly. Any issues related to your data transformation, serialization, or communication protocols can be uncovered. Next, configuration issues. You've got lots of config values everywhere, scattered around probably. You want to validate if this misconfiguration at any point would cause any issues. And then with these integration tests, you can easily simulate these misconfiguration and catch issues before hitting the production. Also, resource sharing. You could easily uncover problems related to shared resources, such as databases, file systems, or network connections. You can catch things like deadlocks or resource contention. And another benefit of integration tests is very easy to integrate into your CI/CD pipeline. Your end-to-end tests, which rely on a real environment, is probably not so easy to incorporate into your CI/CD pipeline. By having these tests running, by investing in these tests, you provide the confidence that your changes won't break your critical functionality. And then eventually, you help yourself deploy updates more frequently and reliably. Another 5 seconds to appreciate the GIF. So yeah, unit tests versus integration tests. I'm not going to say don't write unit tests. Obviously, you should be writing unit tests all the time. But there are some cases that unit tests might not cover everything. One of them is concurrency and parallelism. You could easily reveal issues related to your race conditions, deadlocks, or synchronization problems that might not manifest in isolated unit tests. Also, error handling. So you can verify your components and handle errors and exceptions gracefully, and your components, one of your components can throw an error and the other component react on this error, and then that way you'd verify what you would do in a real world scenario. Also, external dependencies testing. So you could evaluate how components interact with your third-party APIs, libraries. Changes in dependencies can lead to defects that unit tests might miss. And ensuring backwards compatibility. You can easily simulate your deprecated state of your data and run whatever version you want against any version of your code, basically. Very quick GIF again. So this is also a way of showing how things not integrating properly. So writing integration tests in a BDD setting. So how this could be useful. First off, test readability. You get shared understanding of your behavior amongst your team members, right? You ensure that everyone is on the same page regarding expected functionality, because you're describing things in a natural language using English. And then also your requirements are clearer. Your scenarios serve as living documentation that outlines your expected behavior. You're helping to just eliminate any misunderstanding, because your documentation is always up to date, because your documentation is generated as part of your tests. Another thing that this helps with is scope creep, because you described your service very clearly with these BDD scenarios. That no product person would be able to creep some scope into your basically your development tickets. Another benefit is quite good with regression testing, because you already documented your functional behavior in case when you develop something new, if your code regresses in some way, you catch these because you've got these all running as part of your CI/CD pipeline. So how to actually do it with Godog and test containers? So the first of the two libraries that I'm going to talk about is test containers. It's an open source framework. It provides basically real instances of databases, message brokers, or anything you can think that you could run on a container. What you do is, if you're using this, you test your dependencies as a code. You programmatically define your containers as part of a test, and then communicate with these actual dependencies rather than mocks or in-memory services. And you wouldn't get data conflicts even if you're using multiple pipelines in parallel, because each pipeline runs in an isolated set of services, which I'm going to touch on a bit later. And it's easy to maintain after test execution. It's very easy to clean up your containers. And this is already supporting many languages, including Go, Java, .NET, Node.js, Rust, and Python. So test containers Go, obviously, a Go package that enables to use test containers. It plays really well with the native Go test framework. It allows you basically programmatically define containers that should be run as part of a test and clean up resources once you're done. So as you can see here, your database client, the Postgres client, is using port number 5432, and you're calling test containers, and inside is spinning up a Postgres container for you, which expects to receive calls on 5432, but it's taking care of the dynamic port assigning. So your application is always behaving the same way in a production environment, and your database also acting the same as the production environment. And because of this dynamic port mapping, you can run multiple tests at the same time. So just to talk about how we do this, it's quite easy to set up. Basically, this function, we're spinning up a Redis container. The line 3, we basically construct a struct for to retrieve a Redis instance, basically. The first thing we need to specify is the image. You specify the image version to retrieve from whichever image library that you'd be using, and then expose ports. Obviously, depending on what kind of dependency you've got, you say I'm exposing these ports, and then you can put wait conditions. Wait until you see this log in my container before proceeding with the test. And then you could set up a network as well by simply giving it a network name. And then connecting to these dependencies from your test. Basically, once you start your container, you retrieve your container's IP on runtime, and you use that connection variable feeding into your service under test as a dependency or configuration, and then you can just simply run your test. The next library I'm going to talk about is Godog. This is the official BDD framework for Go. It merges specification and test documentation into one cohesive whole using the Gherkin format I specified earlier, given when then. So here we've got a feature. The feature is called lookup promotions on the home feed. Home feed is basically when you're on the Deliveroo app, where you see all the restaurants, offers all together in one feed. So as a consumer, I want to, in order to choose where to order from, I need to be able to see which promotions are available on the home feed. So in my scenario is a zone promotions available for the user's location. The first step of the scenario, given a free delivery promotion is available for the Mayfair zone, when I call lookup promotions with my zone set as Mayfair, then then the response should contain a free delivery promotion for my zone. So this is how you define a scenario, and then we're going to look at how this actually translates into Go. You need to have backend Go functions for each of your scenarios. As you can see, we're using regular expressions to map this human readable language, human language statements into Go functions. For example, at the top, we've got our given scenario. Given a, oops, didn't mean to go ahead. Right, given a parameter is available for the parameter. And my Go function is actually expecting 3 parameters, and I'm basically setting up my tests using these parameters, promo type, zone, etc., etc. Next, the when implementation. Again, when I call lookup promotions with my parameter set as parameter, my Go function has got 2 parameters but an additional context. What might I need the context for? Any ideas? Sorry? Yes, that's correct. The gentleman here said the pass value between the steps. Thanks for the right answer. You got a T-shirt, test containers. There you go. Yes, exactly. For that reason, you're using context to store data between steps. Because here in this function, you're making a call to the service, you're getting the response. But not in this step, you're evaluating your response. I need my response to evaluate in the next step. What I do is, in the next step, here in line 1 to 3, I'm getting my response, and then do all my evaluations, and then do my test report, etc. And for your test execution, before you run your test, there's a few options you can do, different style of formatting, like pretty, progress, JSON, or your own custom formatting. And basically, you need to specify your feature folder where the text file is stored for your human readable test scenarios, and then you run your test as like the rest of the Go tests. So I'm going to do a little demo. For that demo, we've got a trimmed down version for our promotions service at Deliveroo. That service depends on 2 main components. One is DynamoDB for storage and Redis for caching. So I'm going to try and demonstrate this, but I was hoping that I'd be hands-free, but I'm going to try my best, hopping between microphone and code. So let's try and switch to Golang. Right. So like I said, we've got a service that relies on 2 main components. Right. One is the font readable, by the way, or do I want it a bit bigger? Okay. Well, I think from the back they said got mixed responses. Let's go a bit bigger. When you're presenting and you can't see the, you're looking for, can I put custom numbers here? Nope, has to be 150. Let's hope this isn't huge. Is that okay from the back? Okay, Okay, cool. So yeah, my service depends on a few things, but two main dependencies are a DynamoDB repository and a Redis cache. Basically, just very briefly going inside. Okay, DynamoDB and a Redis cache. Right, so to be able to integration test this service properly, I need these dependencies fulfilled, right? So, and my service exposes a gRPC endpoint called lookup promotions. So this is everything my service works with, is this folder. I'm going to the next folder, which is the integration test folder. And everything that I'm going to be using as part of the integration tests I've talked about today, test containers and Godog, they're all inside this folder. So it's nothing huge, it's very easy to set up. First thing is I want to basically show the feature file. It's simple as that. Any product person can write that. You don't have to be a technical an engineer or some specialist role to write this, as long as you're familiar with the product. So you can write this. As I mentioned, you've got parameterized words in here for your Go functions to look out for. And what happens then? In your test file, you've got your initialized scenario, right? Given, when, then, all your human readable statements are mapping to your Go functions, as I briefly mentioned in the slides. So these are how you fulfill the Godog, but you still need to specify your dependencies, right? What you do for that is basically when you start running your test, first you initialize your Redis container. Let's go inside. What I do is just like the slide. I specify my image, my port, my wait statement, and my network. Let's go back to have a look at DynamoDB. A few more things in there. You can send more things. So again, I specified my DynamoDB image. This time I specified some commands as well. When my container spins up, execute these commands, my ports. And this time I also specify a port to become available before proceeding. Make sure this port is available. Another thing I do is I'm sending some environment variables as well. Depending on your test scenario, you can send some wrong environment variables or your correct environment variables, see how they would react. Try and navigate back. Yeah, so I've got my Redis container, DynamoDB container all set up. And I use these, their IP addresses dynamically generated at runtime. And I send these details to create my service under test. And then I spin up my service under test container. And then using that container's dynamic address, I create a gRPC client so that I can call my service completely independent, so that I don't rely on any libraries that's shared between the test and my actual service code. So I'm testing it from the outside as close as possible to a real world scenario. And finally, I set up my Godog variables, basically specify the format, the feature folder, and execute my test. So after test execution, if everything's all good, basically you just close your connections, terminate your containers, and then all done. Let's quickly execute this. Let's clear the console. Let me quickly show you. I'm gonna show you that I haven't got any containers running right now. As you can see, I haven't got anything running. So all I do next is basically run a go test command. So go test, I've specified my integration service folder, integration test folder, and start the execution. Right, things are initializing. Let's have a look what's going on. First thing we see is a test containers Ryuk image being created, downloaded. This is like an admin image that brings all the other containers that you need for your application. Next, you've got Redis being pulled down, all being set up. After Redis, you've got your DynamoDB being pulled down, and then these two right now are being fed to your service under test. If I quickly switch to a different terminal, you can see now I've got containers running. And switch back. Oh, tests have already passed. So let's scroll a bit back up. Here you can see with my dependencies, my service, my gRPC service under test is initialized. And then now I can see my scenarios all executed, given, when, then, all green. And you get a little report, how many scenarios executed, how long it took, and containers being terminated, and your test report and overall time. So if I were to execute Docker PS, all gone, all cleaned up. Next thing I'm going to talk about is how easy it is to extend your scenario. Say I wanted to add a new scenario, right? Let's quickly modify a scenario. If I talk without the microphone, can you hear me at the back? Yeah. Right. So what I'm going to do next is, instead of a delivery fee promotion, I'm going to create a voucher promotion in my scenario. That is available for, let's make sure this only works for restaurants and not parameterized restaurant. Given the voucher promotions available for Burger King Leicester Square, when I look up promotions with my restaurant as Burger King Leicester Square, then the response should contain a voucher promotion for my restaurant. So let's go ahead and execute this. Again, my container is being created. Let's check back on the other side. Yep, DynamoDB upgrade is up, and test container admin is up. And as you can see how the ports are being mapped. And switch back. This should hopefully not take long. Because of the failure, it might take slightly longer. Because, well, I gave it away, didn't I? It's going to fail because I created a new scenario and I didn't implement it with a Go code. But what Godog does it for you is, oh, you've got an undefined scenario, but here you go, you can use this regex, regular expression, to add to your initialized scenario, and then basically just copy this code snippet into your code and include into your scenario initialization, and copy this other code for your function scaffolding, and then implement your function step. So this is pretty simple. Once you have that running, you can easily build on top. The final thing I'm going to talk to you about, because the idea behind BDD is the collaboration between technical people and non-technical people like product people. What we did was we basically output our latest service execution results onto Confluence, so non-technical people without they have to have Git access for some reason, but without any local dev setup, they can go and see this. So all this is generated directly from our CI pipeline, and you can see the test report, and it actually tells us which the branch, which part of code that you executed